All right, guys, let's look at our lesson 10.1, lines that intersect circles. So we're going to talk about a few new vocabulary words that you're not used to seeing with circles, and we'll review the ones that you have seen. The first one here is the word chord. So I'm going to show you what it looks like first, and then we're going to talk about the definition. So a chord basically is a line segment, which means it's going to start and stop, and it's going to go through the circle. It doesn't have to go through the center. It can go through the center, but this right here is a representative of a chord. It's going to start and stop on the edge of a circle. So this right here we would write as chord. Now, the term that goes through the center on both sides, remember, is called the diameter. The diameter is an example of a chord, but not all chords are diameters. So there's a difference between those two words. The next word that we're going to talk about is the word secant. Secant is a lot like a chord, knowing that it goes through the circle at 2 points, but instead of a segment that stops, this one's going to be a line that's going to continue through the circle instead of stopping like the chord. So this one right here is called the secant. The next one we're going to talk about is the word tangent. Tangent is where you have a line that goes through the circle only at 1 point. So it just kind of scrapes the edge of the circle, doesn't go through it, it just touches at 1 point. So we would say that this line right here is the tangent line. The point where the tangent line touches the circle, which is right here, is called our point of tangency. And this vocabulary word, or all these words, are very important for the circles unit. So I'm going to avoid, just for time's sake, of writing all these definitions out. They are going to be on Schoology with all this as a key. But as a review, let's just talk about the words again. Chord is a segment, so it's going to start and stop, but it hits the circle at 2 points. Secant, the difference between a secant and a chord is that the secant goes through the circle. It's a line. Then we have our tangent line that only touches at 1 point, and that point that it touches at is called our point of tangency. So let's just do some review of all those words for a second. So our center, and we're going to name it. So remember, when we name things, we use capital letters. So the center of our circle, we name it as O. Okay. Radii, just as a review, remember radii starts at the center and goes out. So we have radii here at OR, we have a radius here at ON, and we have a radius here at OM. We could name a couple other radii here, but they're not connected, so we're not going to worry about those. So we can write it as OR, ON, and OM. So OR, OM, and ON. And because those are segments, we will put the line over it. The next word that we're going to talk about is chords. We just talked about that on the front page. Remember, it's a segment that hits a circle at 2 points. So we see here one at MN. Even though it goes to the center, that's okay. It's still touching at 2 points, MN. Another one here is MT. Now, it looks like it's a secant because it goes through the circle, but if you write it as a segment, it's considered a chord. So we can say MN and MT are 2 chords. And remember, because they are segments, then we have to label it as a segment, okay? Secant, remember, goes through the circle, and I only see one here, so we would name it MT. And the difference between this MT and this MT is that we would name it a line instead of a segment. Next one is a diameter, an old term that you learned back in the past. So we know a diameter hits the circle at 2 points like a chord, but it has to go through that center point. So our only diameter here that we see is MN. And because it's part of the chord family, we label it as a segment. Then look at our circle, we can see we only have one tangent line. We can see this right here at PS is our tangent line because it's the only line that touches the circle at 1 point. So PS, and it's written as a line here, so we have to write its name also as a line. Then remember, the point of tangency is where that tangent line goes through, so it's hitting at point Q. And so that is our point of tangency. And there's our vocabulary. A couple of theorems that we're going to learn with 10.1 is that if a line is tangent to a circle, so we're looking here at line AB, so see how AB is tangent to the circle, then it is perpendicular, and I'm going to emphasize that word perpendicular, to the radius drawn to the point of tangency. Remember, perpendicular means that two lines come together and they create a right angle. So anytime you have a tangent line and radius coming together, you get to automatically make that into a right angle. And we can see here that now we have a right triangle. And so we go back to all of our right triangle rules that we've learned this year. They are asking us in example 2 to find the measure of angle X. And so if we go back to our rules of circles that we learned in the past, we know that BC is a radius, and also this line here, and all radii are the same, which means we get to automatically make that mark as 5 also. It's not looking for the length of that, it's looking for this, which is part of the hypotenuse of our right triangle. And we know that when we have right triangles and we are given lengths of two sides, then we can use Pythagorean theorem to help us find that. So let's set that up. I'm going to zoom in. So 5 squared plus 12 squared, because we are looking for part of the hypotenuse. 5 squared is 25. 12 squared is 144. We combine those two together and we get 169. And we know at the end of Pythagorean theorem we always have to square root. And so C would give us 13. But be careful with these questions, because a lot of times it's not asking you to find the length of the whole line, it's asking for parts. So remember, we used our knowledge of radii to know that that was 5. If the whole thing is 13, then we can say 13 minus 5, and that gives us 8. And we can say that X is going to equal 8. Okay. Next theorem says that if two segments from the same exterior point, so it's talking about point 8 here, point A, are tangent to a circle. Remember, tangent means it hits a circle at only one point. So you have tangent line AB, tangent line AD. They're both coming to the same exterior point at A. Then they are congruent. So we know that these two lines, AB and line AD, are congruent. And anytime we have two congruent lines, we've talked about all year long that we have to set up part equals part. So we can set 2x minus 13 equals our 48. Okay. We can move the 13 over. And we can say that 2x equals 61. Divide by 2, and x equals 30.5. Okay, so that's what x equals. That answers our very first question here. X equals 30.5. Based on that theorem that we learned here, that these two tangent lines are going to be congruent. Has nothing to do here with this middle line that connects to C. The next question is asking is the measure of angle ABC. So when it's asking for angles, remember, we kind of trace over it with our pencil or our stylus, whatever we have. And so if it's asking for ABC, this angle right here, let me erase so we can see exactly what it's talking about. So this angle right here, we know that we have a tangent line and a radius coming together. From the previous theorem, we learned that those are always perpendicular, which means it creates a right angle. So we know that measure of angle ABC is 90 degrees. Now we look here at the measure of BC. BC is a radius. We don't know anything about it other than that we have a right triangle here. We actually have two congruent right triangles. So we could go ahead and use this bottom one here because we already have the information of two of our three sides, and we get to use Pythagorean theorem again. So we know that's also a right angle because of a tangent line and a radius. 52 is our hypotenuse because it's across from the right angle. So we can say 48 squared plus b squared equals our 52 squared. If we do the math in our calculator, which I know you guys can do, we know that b is going to equal 20. a nice pretty triple for us. So our radii are always going to be 20 here. So we can say the measure of BC is 20. And if that's a radius, then if we look for a diameter, we know we can just double it, and our diameter would be 40. Okay, last example here that we're going to talk about is just some vocabulary from the whole lesson, naming the following. So if we look here at OC, they're talking about this line here, OC, from the center to the edge of the circle, and we know that that is a radius. Okay, the next one, ED. ED connects edge of circle to edge of circle going through the center point. And if we have that scenario, then we know that yes, it's a chord, but the best name for that is the diameter because it is going through the center point. The next one that it's asking for is segment AB. We can see that segment AB only touches the circle at one point, at point B being our point of tangency, and so that would be a tangent line. Last thing is measure of OCA. So let's highlight that just so that we can see it. OCA is right here. We have a radius coming together with the tangent, and we learned in our theorem that that's always going to create a right angle, so that is going to be 90 degrees. Just to recap, couple of new things. We know that a chord, I'm going to go back to the very beginning for us. Remember, a chord hits the circle at 2 points but starts and stops. Secant hits 2 also but continues on, so a segment and a line, and then a tangent line always hits at 1 point. All right. See you guys tomorrow.